Okay, here we go. Unit 1 is all about graphs and expressions. We'll start the first couple sections talking about graphs, and then we'll get into some expressions at the end of the unit. We'll start with 1.1, creating and analyzing graphs. Okay, the first thing we have is we are going to work on some scatter plots. I know you guys are familiar with scatter plots. They are done on coordinate planes, and you're basically just plotting points that represent some information. In this case, our information is about a Froyo store. Frozen yogurt's my favorite. And we are talking about one that charges their cost based on how many ounces that you purchase. So we can think of these all as ordered pairs. We know that this is our x value and this is our y value. Just based on a normal t-chart, your x value always comes first and then your y value. So we would have 2, 1, 5, 2.50, and we could continue this all the way down. When we talk about an independent variable, it's kind of the standalone one that you're talking about. So fancy definition, it's the quantity that's being manipulated. It's standing alone. You can change it, it can change, but it's not changing dependent upon anything else. So we can have different amounts of ounces, but that doesn't depend on anything else. Whereas the price, the dependent variable, that's the quantity whose value is depending on manipulating the weight. So if we change the weight, the price will change based on that weight. The price dependent on the weight. The weight doesn't depend on the price depends on the weight. Okay? Independent variable, that is your x value. Dependent is your y. We know when we're working with a coordinate plane, it actually has 4 quadrants. 1, 2, 3, and 4. But in this case, all of our values are positive, and that occurs in quadrant 1. So we're only going to graph on quadrant 1 for this one. When we do that, we need to have lots of labels. You need a title for your graph, and I'm just going to call this one Froyo. And we will need to label our axes. Our x-axis, again, is your independent axis. And in this case, we're talking about weight in ounces. And our y value is our dependent axis. And in this problem, we're talking about the price in dollars. Next thing you need to do is you need to figure out what you're going to count by. What is each line going to represent on your coordinate plane? In this case, on the weight, we're going from 2 to 14. But bad news, I don't have 14 different lines. I think I have like 12. So I can't count by ones or I'm not going to be able to plot my last point. You have to think of a different scale to go by. In this case, I think we can get away with 2. So 2, 4, 6, 8, 10, keep going. And we know we're not going to plot anything past 14, so I'm going to go ahead and stop there, although you could keep labeling. For your y-axis, dealing with price, you're going anywhere from a 1 to 7. And so I can just count by ones on this one. If I were only counting maybe 1 to 4, I'd probably want to go by 50 cents, by 0.5 to spread the graph out. You don't want to have the graph just be in like a tiny little corner. You want to use as much as you can of the graph. Okay, so then all you're going to do is plot your points. These are ordered pairs, x value and y value. So where to go on your x, where to go on your y. So 2, 1. Now remember when we're saying 2, we're not going to go over 2 units because we're already counting by 2's. So just go to where you've labeled your 2 and up 1. Next one's 5. I don't have a 5 label, but of course I know it's between 4 and 6, so halfway between, that's your 5. And same thing, I don't have a 2.5 label, but I know that's halfway between 2 and 3, so place a point there. 7, 350. Oops, I'm erasing the wrong spot. Didn't want that there. And I left off my H. Okay. 9, 450, 12, 6, and 14, 7. Notice that you have a nice linear pattern here. You don't need to draw a line through. With a scatter plot, you're just putting your points in, unless you're specifically told to put the line in to connect them. In this case, we're not, so we will leave it that way. Notice that even though my y values were irregular and my x values were irregular, and by irregular I mean here I jumped up 3, here I jumped up 2, 2, 3, 2, so it's not the same increase every time. When you go to label your graph, you have to make them the same increase every time. So I always went by 2s. I didn't just choose to label 2, 5, 7, 9, 12. I didn't use these numbers. I used a nice, neat pattern, going up by 2s here, going up by 1s, even though that's not what happened in my t-chart. Your graph needs to be regular. You need to have a regular pattern. Okay? So there's our first one. Let's try another one. Whoops. This one is about the score of a player on the game show Jeopardy. So as time moves on, as the episode goes forward, what is that player's points? What do you think the independent variable is here? We know when we're working in a vertical t-chart, it is generally your first one. But this one's horizontal. No big deal. Guess what? It's generally your first one. Another big key, anytime you see time never depends on anything, right? Time just keeps on moving. So it is your independent. We'll call that T for time. You could have called it any variable you would want. And again, remember that's really your X value. Dependent is your Y. But sometimes we like to be creative and use a different variable. Let's say S for score. Okay, notice what quadrants you've been given in this coordinate plane. Quadrant 1, and quadrant 4. All of our X values are positive, and our Y values are positives and negatives. Okay, so here's your origin right there. That's your 0, 0. So go from that. I want you guys to pause the video and finish your chart. Make sure you label your units, you label the title, and you put your numbers in. Okay, pause the video and go ahead and do that now. Okay, check my graph out. Hopefully you've got something similar to it. I chose to count by 2s on my time axis, my x-axis, since I couldn't count by 1s and get to 25. Counting by 5s, your graph would only take up this small, it'd be 5, 10, 15, 20, 25. You'd only be using this portion of your graph over, so that would be too much of a gap. So you want to use as much as possible, but fit your whole graph on there. On my y-axis, I counted by 100s, labeling those. I labeled what I was talking about here and here, and I gave a title to my entire graph. And then I plotted my points. There they are, up and down. Make sure you did not label 3, 8, 11, 15, 18, 21. You can't count by those. You could not have put 3. Let me use a different color. You could not have done 3, 8, 11, 15, 18, 21. Those aren't the same gaps each time. Here you'd be going by 5, then by 3, then by 4. You cannot make a graph like that. Likewise, it would not have made sense to over here go 100, 500, 700, 200, negative 300, negative. That's not how we count. Okay, so you need to make sure you are going by the same interval each time. Okay, next up, the running man. Mr. Bruss likes to run to work. Good for him. The graph below shows the distance Mr. Bruss is from his house over the course of his run. So we're working time in minutes and distance from house in meters. Which one of those would be your independent variable? If you thought time, you are correct. It's on your x-axis, and again, it's time. Okay, so let's put that in our first column, time in minutes. And distance from house then has to be your dependent variable. And we're working in meters, M for meters. Okay, let's fill out our chart. So at 3 minutes, Let me make this a little bigger for us here. At 3 minutes, he looks to be exactly 400 meters. Fill that in. At 5 minutes, okay, it's not quite exact, but it's between 600 and 700, maybe a little more than half. So let's do this symbol. That symbol is like a squiggly equal sign, and that means approximately equal to. Okay, if you haven't seen that before, it means it's approximately equal. So what did we just say it was at 5? Let's say, oh, I don't know, 675. Maybe you're in the ballpark, 660, 650, that's fine. 7, he's 800 meters. At 9 minutes into his run, he's still at 800 meters. Okay, now we're looking at the other way. We're looking what's happening at 1100 meters. So we're not going to look down here. We're going to go up here to 1100 meters and go over till we run into our graph. And it looks to be about a little more than 11. So let's say that's maybe 11.2 minutes. 11 minutes, some amount of seconds. 1600, ooh, that's interesting. There's 2 boxes. What do you think that means? Well, let's see what happens at 1600. Going over at 1600, ooh, here's a point right here, but there's also one here. So that's why you have the 2 boxes. There's 2 different spots where it's 1600. That occurs at 13 minutes, and it also occurs at 17 minutes. Okay, so we filled in our chart. Okay, so if we're looking at this graph, there's a lot of different lines happening. Okay, so there's a portion of a line here, and then we stop, and then we flatten out, and then we start going up again, and then down, flat, and up. So we can break that into the different intervals where things are happening. So we can say that from 0 to 6 is one interval, right? Kind of went past that there. From 0 to 6 is one interval where the same thing's happening the whole time. And then we have something different happening from 6 to 10. And then from 10 to 13, right? So we can talk about what's happening in each of those intervals. 0 to 5, 6 to 10. Oh, that should be 0 to 6. You can go ahead and jot those down into your notes. Okay, so from 0 to 6, we are increasing. You always read a graph from left to right. So going from left to right, you're moving up, you're increasing. Okay, don't read it backwards. It's not right to left, always left to right. So that means as that time, during that time interval, as time moves forward, the distance is increasing. So he's getting further from home. Further from home is what's happening. The graph is increasing. He's getting further from home. From 6 to 10 minutes, what happens to the distance? It's always 800. It's staying the same. So if it's staying the same, what's happening? Well, it's constant, we can say, first of all. And that basically means he's not moving. Maybe he's tired, maybe he stopped and saw somebody new and he was talking, maybe he saw a cute little puppy he needed to stop and pet. But for whatever reason, he's not moving from 6 to 10 minutes. Okay, then from 10 minutes to 13 minutes, it's increasing again. And we know when it's increasing, that means he's getting further from home. From 13 to 15 minutes, it's doing what? It's not going up anymore, it's going down from left to right. That is decreasing. Why might he be decreasing? Why would his distance, when the graph is decreasing, he's getting closer to home? Why would that happen in the middle of his run when he's trying to get to work? Well, maybe the route he takes, he has to go down away from the school to get back to where he needs to be. And then from 15, or maybe he dropped something. Ooh, that's interesting. Maybe he dropped something and had to go back and get it. And maybe this right here, from 15 to 16 minutes, where it's constant and he's not moving, maybe that's where he stopped to pick up whatever he dropped. And then from 16 to 20 minutes, again, we are increasing, or I should say our graph is increasing, which means Mr. Brust is getting further from his house. Okay? And you can imagine that if you were at the end of the day, if you were going back to his house, his distance from home in some way is going to go from here back down to 0. So maybe maybe he has an easier time. Maybe he just comes straight back home and doesn't take him as long. Or who knows, maybe he goes and stops at the corner store and he goes shopping on his way home and then he continues on home. Or maybe he starts heading towards home, is running home, and then he gets tired and he doesn't want to run anymore, so he just starts walking. Well, it would still be going towards his house, but not as quick of a rate. So maybe it takes him a little bit longer to get home because he starts walking. So lots of different things could be happening in one of these graphs. Question, the point 1800 means. What does that mean? What does that mean in relation to this graph? Well, 18 we know would be our x value, so that would be our time. So we're talking about 18 minutes. What's 1800 represent? That would be your distance. So 1800 would be this, this point right here. This would be meters. And what does that mean, actually? Write yourself a little sentence. You will be asked to do this. At 18 minutes, into his run, Mr. Brust is 1,800 meters from what? From school, from his job, or from his house? Remember what we're talking about? It's his distance from the house. Okay? So all you need to do, essentially, is just put the labels with each number and make a sentence out of it. At 18 minutes, he's 1,800 meters from his house. Okay, story time. Professor Splash set the world record with he did a 36-foot belly flop into a 1-foot pool of water. And we're going to sketch a graph of his height over time. So, which one is, first of all, you're going to be positive in both height and time. You're not going in any negative, so just quadrant 1 would be all you would need. Think about which one is independent, which is going to change, and which one is going to change based on that manipulation. Well, time's the dead giveaway, right? Time is independent, and that means the height is dependent on the time. Okay, so pause the, well, actually, let me show you a video of him doing it first. Show you a little video of Professor Splash. Here's another view of that. It's a different jump. Whoa. Nice. Nice. Okay, so go ahead and draw a sketch of that and pause the video to do that. Okay, hopefully you'll label some number up here, which should be 36 feet. You could label that we are talking about height in feet. And maybe you drew something like this. Or even better, maybe you came like that. And maybe you're really thinking what to do with that 1 foot. You could label that 1 foot and draw some nice water in there. There's your pool. You don't have to have that though. A perfect graph would look something like this. Okay? Took them about 1.5 seconds to fall into that, it says. Okay, so check your work, see how that went. That's all we got for you. So now you're going to go ahead and fill out, summarize your notes at the bottom there. Any key points you want to make sure you remember, anything that really stuck out to you. And then you're going to work on the rest of the problems in your packet. And good luck on your mastery check.